Hello everyone, welcome to Institute Pharma Chemistry Genius. Today we will start with Wolff Kishner reduction reaction. So this is a reduction reaction of organic chemistry, okay, and then we will also learn the mechanism of it, how you will solve the mechanism and find the products using different examples. Okay, so conversion of carbonyl compounds, that is your ketones and aldehydes, okay, to methylene group. That means what happens is that to the reduction means addition of hydrogen and removal of oxygen completely. So aldehydes and ketones has C double bond O group, so the oxygen will be removed and this will be replaced by 2 hydrogen. That is only your reduction reaction, okay, and this is done in this reaction with the help of their you can say methylene group, okay, and this is done in the presence of your succinic acid and hydrazone, okay, in the strong base such as C2H5ONH and NaOH. So these are very much strong bases. So see here, if you take a ketone, that means R1C double bond O group, and R is nothing but your alkyl groups. Any kind of alkyl group, it can be saturated, unsaturated, or you can say cyclic ring, anything. Okay, so see here, when you react with NH2 and NH2, that is your hydrazone, and if you write it in the form down, I have written H2 and NH2. And if the water molecule goes out from the reaction, then you get an intermediate R1 C R2 double bond N NH2, and this one, if you react with your strong base, then you are going to get your alkene group. That means your oxygen will be removed and hydrogen is added. So this intermediate compound is called your semi-carbozones, or you can say the hydrozones of aldehydes and ketones. It is unsuccessful for sterically hindered ketones. That means if you have bulky groups of alkyl group, or if you have benzene ring bulky, then what happens is that this is unsuccessful reaction. But if you reach KOH, okay, and ethylene glycol in the presence of your hydrazone, okay, if you use these two compounds, then it also goes for reduction reaction, and that reaction is called your Hungs-Millens reduction reaction. Okay, so that is, and this KOH and ethylene glycol is the Hungs-Millens reduction reactions, you can say, reagent, and the severity of the reaction can be reduced. Severity, that means like has to be done in a very much high temperature and pressure. So to reduce it, okay, to reduce the temperature and pressure, we can use some reagent other than what is given to us, that is your hydrazones, okay. So it can be brought down to normal temperature if you have this kind of sterically hindered ketones, okay, and if you react with hydrazone, that means again you are going to get benzene ring, carbon, and double bond N and CH2 group is there, okay. But this time what you will going to use, you will use CH3C, CH3 tertiary butoxide, okay, potassium butoxide, and you will use dimethyl sulfoxide, okay, and then it is done under 30 degrees Celsius, so the severity is reduced, and you again the carbon and oxygen group are reduced and hydrogen is added in place of it. So dimethyl sulfoxide is used in order to break down the temperature, okay, the severity of the reaction can be reduced. Now say we will go for the mechanism. So mechanism of Wolff Kishner reduction is that, so if you have these kind of, suppose this is your ketone, okay, and you have NH2 group, so you know nitrogen has a lone pair of electrons, okay, because it has 5 valencies. 2 is bonded with hydrogen, 1 with nitrogen, and another 2 electron is left in the outermost shell, okay. So now what will happen in, or you can say p orbital, so this 2 electron, now it will go and attack the electron deficient carbon atom, okay, because oxygen is electronegative, it will pull the electron towards itself, so it is taking the minus sign, and then this nitrogen, the lone pair, will go and attack it to the carbon. And now see, this is the intermediate molecule which is formed. Now what happens is that this oxygen will take up the hydrogen from the nearest nitrogen, and now it will form OH and then NH and H2. So now, and then there is CH3 groups added to it. Now what happens, see this, again there is a lone pair on you can say the nitrogen atom, it has access of electron again. So what it will do, it will come into the, so if you write this one, see, okay, so if you rearrange this molecule and write like this, so there is a removal of water molecule from this one, so OH, after the water molecule leaves, then you have double bond C double bond N and H2, and there is a CH3 group in it, okay. Now this molecule also you can rearrange it and write like this. Okay, see, if there is a benzene ring, carbon, CH3 group, double bond N, NH2. Okay, now again there is you can say base in the reaction medium, we know. So this base OH minus of ethylene glycol, or you can take any OH and C2H5, it will take up the proton from the nitrogen, adjacent nitrogen atom, and then again there is a shift of double bond. Okay, so then there is a minus sign on the carbon atom. Now this minus sign will take up water, hydrogen from the water molecule in the reaction, and then again see there is one hydrogen has come to the carbon. Again this OH minus will take up proton, and then again there is a removal of nitrogen in this case, and there is a minus sign in the carbon. This minus sign will take up the proton, and there is again the base is formed. So OH minus is formed and your reduction is complete.